Okay, hi, Martin here. I wanted to ask, like, if I have an application that uses Postgres, and let's say it's a microservice, and then when would you keep the Postgres in the pod with the application, and when would you keep the database in a separate pod?
Well, you know, one of the things I will be mentioning today, it's a good question, and it's all about best practices. One thing that I think should not be changed dramatically is what you consider a best practice in the non-virtualized or non-containerized world versus what you consider in containerized world, right? So the question would be the same. Would you run a Postgres database alongside your application on the same VM or bare metal host? Typical recommendation is obviously not to do that, right? So from that perspective in containers, I would say the same. Would you run them co-located into the same pod? Absolutely not. Would you run them co-located in the same node? Well, that is one of the reasons why you typically go containers, to improve the packing efficiency, to save some resources. But typically, if you run a production database with a noticeable workload, that won't be a good recommendation either. So I would even recommend for the database we run for our customers, we always recommend to have dedicated nodes, physical or virtual, for that. And the same you can do in Kubernetes, where you can say, this node is only for the database cluster. I hope that answers your question.
Yes, it does. Thanks.
There's one question on the chat. Have you some experience regarding PG in Kubernetes, but when on Kubernetes istio.io service mesh is installed, and could you say anything about such setup?
Yeah, okay, that's a very good one, and it's something we also considered for StackGres itself. Istio actually is two things at the same time. One is an Envoy proxy fronting every unit of deployment. In our case, the unit of deployment is a pod which contains Postgres and many other things around. And you can think of the master and the replicas. So each master in each replicas may have one envoy in front of it to proxy all the traffic. This gives you a lot of capabilities, a lot of advantages. You can monitor this traffic very well. You can get a lot of performance metrics out of the envoy proxies. You can play games kind of to shut down traffic, to rebalance the traffic, to do canary deployments. You can offload SSL to envoy proxy. So all these are really, really good reasons to front end each of those Postgres servers with an envoy proxy. And unsurprisingly, that is exactly what we do in StackGres. We have an envoy proxy deployed in front of every pod that runs Postgres. But at the same time, Istio is now the control plane. It is a set of components that talk to all these Istios deployed and configure them and deploy them certificates and gather the telemetry and all these things. And Istio, this control plane, is actually quite complex part of software and has a lot of interactions. It may become so much complex that might not be at some point worth the effort. So the envoy part is very cool. The Istio part requires a lot of thinking. So at some point, it might not be recommended to have Istio with all its complexity to handle our Postgres workload. We don't consider it's at that point yet. Maybe in the future will evolve, will become more simpler for some reduced use cases with regards to all the flexibility that Istio otherwise provides. So for Postgres case, we don't see yet the need for Istio. Now, what happens when you try to deploy this on a place where there is Istio already installed, right? Because Istio automatically injects Sidecars, envoys, proxy, and their configuration. So, well, actually, it's quite simple to avoid this because Istio supports an annotation that prevents injection. So as long as you deploy your workloads, adding the annotation for Istio to prevent injection, then Istio will leave that part separate from the rest. And then you don't strictly need anything. You can ignore Istio for that deployment. Let me know if that answered the question.
hope it does, Tomek, right?
Okay, any other one? No, if not, I'm ready to start.
Tomek got like additional one. I meant that are there some KitKats when working with PG and Istio, but okay, that's good explanation.
Okay. Okay, thank you.
Okay, so maybe like from me, like
hello.
Oh yeah.
Can you tell about using shared file system for Postgres? About what kind clusterfs on.
Okay, yeah. So this is not specific to Kubernetes, but it's common on Kubernetes to have or to have at your disposal a distributed file system, which sounds compelling for Postgres because, well, after all, you don't care too much about local storage, and since everything is ephemeral and things can be destroyed or recreated, distributed shared file system, something that all pods can connect to regardless of who they are, and seems pretty simple. However, even though theoretically Postgres works on distributed file systems, the experiences that typically is not a good idea at all. I don't particularly recommend running Postgres on any distributed file system because it's not a setup very usual, and as such is not very well tested. And because unless you take a lot of care, you may introduce some file system assumptions that Postgres is not built with, and that may lead to things as bad as data corruption. Let me take you an example, NFS, which is one of the simplest and most deployed. If you run Postgres on NFS and you don't take a lot of precautions, for example, to use hard mount option, which means that on any network hiccup, everything will be absolutely stalled. Then, so if you run with soft, for example, mount options, then you'll have a high chance actually to corrupt data. We have had to recover for many customers lost data of a Postgres database because of using NFS as a storage for this without hard options, which nobody wants to use with hard in practical terms because it hurts significantly availability. So this is about NFS. What about other modern distributed file systems that are right now available, like CIFS or others? Well, the problem is that they are not very well tested. I don't know of a lot of deployments using them, and maybe they are correct from this perspective and they solve this problem that NFS has, but we have a few data points about their durability, and we have definitely few data points about their performance. So Postgres has been built with different assumptions, and so today I would totally recommend using network storage, but which is local to the pod. So in other words, something like if we're talking in Amazon and an EBS or in general any network drive on the cloud, or even if you're on-prem, a SAN drive, and to use that for local storage, from the pod perspective, of course.
Okay, thank you.
And actually, because me and Rafa also, the guy that just asked the question, so hi Rafa, we've got like a common friend that is like in Formix DBA, and he always like asking if Postgres has written the data or it haven't written the data, because Informix has for sure. And doing like the analogy to the latest fsync problem with Postgres, and taking the fact that Docker like is introducing like the layer of abstraction. So do you see any like risks of like setting Postgres on like any kind of containers, not only Docker? In case of data corruption, just what you've just said in the context of like distributed file systems?
Well, no. There's obviously two ways of having a storage for a container. One is the container local storage, and the other one is external storage. Things like on Kubernetes persistent volumes. The first one is pretty obvious. It's not interesting at all for Postgres because this storage is ephemeral, which means if the container dies or is rescheduled or whatever, it will disappear. And second, it's not very high performing because it's typically laid on top of a kind of union file system or equivalent, which is not very high performant. So this is not the case, obviously, for Postgres storage on a container. So without local storage, we are using persistent volumes, typical use case. And persistent volumes, speaking in Kubernetes, again, they're pretty well laid out. They just use external plugins that connect to a given storage system under the hood, and that connection is practically direct. So there is no special differences between running storing data on a persistent volume exposed to a container or just from a process. You know, after all, container is just a process, right? Just with a light virtualization around it. I'll explain this in more detail during the talk also. And then, so there's no significant difference in what you will have there. And I don't see any reason and haven't heard of any reason why there would be data corruption because of this layer of indirection. It would happen to many other applications other than Postgres. And I think this is well done in containers.
Okay, thank you. And we've got another question from the chat from Pablo. How one debug Kubernetes installations?
Okay, that's a tough one. That's a tough one because then the question actually should be, how do you debug the application or the Kubernetes system itself, right? The latter I will not answer directly. It's you know, it is a hard topic actually, and you need to go back to the Kubernetes stuff. But if it's just your application that is running on Kubernetes, actually debugging is not that much you know, easier like to run a classical debugger, because maybe the debugger may not be installed in the container that you're running, but actually tracing applications is very well known. And if you develop your application such that it will emit traces to a tracing system, call it Jaeger or equivalent, and you get a lot of information from there, which is able to help you get information about your application. Now, if Pablo, you're thinking more about, okay, as a sysadmin, as a classical Postgres DBA, how do I do my stuff that I normally do without containers, right? So then you have a lot of options, and this really depends on the system that is built and how the containers are built, and whether those tools that are typically available for you are also available as part of the container image that runs your Postgres image or whatever. And I'll briefly also talk about this during the talk. How we approach this problem, and is something we are concerned about. And in general, except for a couple of exceptions, you practically can do almost anything that you can do within a container that you can do otherwise. Because again, and I will insist on this, a container is just a light wrapper around the process. So it's not like a virtualization magic that hides away too much data from you. You're actually running things on the host anyway. Yeah, so I'm reading from the chat. Thank you for the information. Yeah, absolutely. If you use a kubectl describe, you can see all the information about an object, and I will be probably using this command throughout the demo. And similarly, you can get the logs from the applications with the log command, even though I'll also make some comments about how to get logs from Postgres in a better way. So yeah, I'll direct this tool. Thank you about the comment about Kale. Yes, that's also interesting. I mentioned Jaeger. Let me just I'll share the URL here in the chat. But there's many like this, so you know. Okay, one last 2 minutes question, and then we'll make it exactly on time.
Nobody wants to ask anything. So I think we can slowly start.
Okay, excellent. So just let me come back in 30 seconds. Just gonna make sure there's enough light here. I'll be right back.
There's another one about PVC configuration.
Okay. So the PVC's persistent volume claim, which is an handle for a persistent volume. And persistent volume, basically, the main points that you need to configure are the size and the storage class. The storage class is a way of defining under a given name the type of storage you want to have under the hood. So typical environments will have different storages. For example, on cloud environments, you may have high performance storage, lower performance storage, infrequent storage, and several other classes, same as on-prem. So storage class will give us a name to a pool of storage you can allocate from this named storage classes. And then if you just configure the size and storage class you want to use, that's typically what it's enough to request a persistent volume, which will be handled through a persistent volume claim. Okay, this is a pretty general question. Containerized database is the future, or people will use bare metal or dedicated server. Well, I think there's no single silver bullet, right? Like there's needs for everything, and I think both are gonna coexist very well. There is a lot of environments where you really want to work on containers because of the speed of development, deployment, and the tooling that it has been and is growing around containers. And there's also the cases where there is a lot of development of on-prem environments where you really want to run bare metal. But in general, I would say that the conveniency of containers is something that blows many minds away. You know, what I'm going to try to show today is actually how a very complex task, which is building a Postgres with a lot of tools around it, what we call the stack of components around it, which you would typically deploy in a bare metal server in, and I'll justify this, even weeks of work, you can do in minutes in containers. So this conveniency is pretty compelling. But there will always be cases for all kind of deployments. I don't think one solution is gonna rule them all. Okay, so if that's good, I think then we're good to start. Welcome with the talk itself, which I'm sure will spill also more questions about this. So I'll get started. Let me share the screen with you. Yes, I want to share the whole desktop, I think. Okay, is this good?
Yeah, I think it's perfect.
Excellent. I don't see what is. No. Okay, whatever, doesn't matter. So what we're gonna talk about today is a solution called StackGres, and in general, the concept of how to run a cloud native Postgres in Kubernetes. So a little bit about myself. You can actually see here from the screen. I founded a company called OnGres, which means on Postgres. And I've been myself a long time user. I'm not sure if as long time as the previous speaker, but anyway, I've been using Postgres for around 20 years, both as a DBA, database developer, and now I focus most of my time on doing crazy things around research and development on database space and trying to create new software and new tools for the Postgres ecosystem. I typically speak at a lot of conferences, now virtual. And so I'm typically around Postgres conferences. I haven't been to the first Postgres conference Europe that was described. But I've been to many others, and also to, of course, many conferences in Europe. And some examples of the projects I've done in the past are TorDB, for example, and now StackGres, which are interesting projects. Also try to do a lot of community stuff. I founded a nonprofit organization here in Spain, but with worldwide aim, which is called the Fundación Postgres, which is aimed to promote and distribute Postgres all around the world. And this is actually the entity that is organizing this Postgres conference in Ibiza. Unfortunately, yes, we had to cancel. It was announced yesterday or 2 days ago, but we'll come back earlier, bigger and better than ever on next year. So anyway, and also was named recently an Amazon Data Hero. Okay, so let's talk about what is the stack problem. So what is a stack? Let's look at some container images, and if you look at a Postgres container image using the Alpine-based distribution, this is around 77 megabytes, which is pretty tiny actually for a container Postgres image, right? If you take a Ubuntu-based image, then you're around 356 megabytes of disk space, the container size. So we can assume that normally in a container, you try to pack only those things that are related to the software you're trying to pack in there, which means that Postgres do not require more than 350 megabytes to run. Actually, it's so much less than that, but it doesn't matter. That means that the essential Postgres, can run on at most 350 megabytes. Because actually, if you look at the source code, well, it's compressed and then you need to compile it, but it's no more than 20 megabytes, right? And this even contains the client utilities, which technically you don't need to run a server. So it's pretty small. Now look about Oracle. You can see at the bottom of the slide, an Oracle container image weighs around 350 gigabytes. That's a significant difference. And how we can explain this difference? Well, this is what we call the stack problem. And the problem is that Postgres is not really a whole system. I call Postgres the Linux kernel. Postgres is a very, very well engineered piece of software that runs the database. But it's like the Linux kernel. It just kind of boots the machine, provides the APIs, the libc and the system calls in the case of Linux kernel, and boots the server and talks to the hardware and all those things, but you need something on top of it. You need like a Linux distribution to run on top of it to be able to successfully do stuff. We'll talk about this right now, but what I mean is that you don't just do apt-get install Postgres and deploy that into production. You typically want monitoring, you typically want high availability, you typically want backups, you typically want connection pooling and many other components, and none of them come with Postgres. Just the client, the command line client. So the difference here in between these two container sizes is that Postgres is like a small kernel. It's like a kernel. It comes, let's say, bare bones. It's very good, but it comes bare bones. Oracle size, despite being potentially bigger in general, it comes with many other tools which form this set that you may need to require to really do a production deployment. So what we say is that what we should need is, okay, if we already have a kernel, and this is a very good one, what we need then is a distribution on top of it. So for me, running Postgres in production is like, we need like a Red Hat of Postgres. We need this distribution on top of Postgres with all the components that are properly packaged, properly tuned, properly configured to work together, and then make this distribution, this set of components on top of it. So let's talk a little bit about the Postgres ecosystem. And I call this Postgres ecosystem a little bit like Dr. Jekyll and Mr. Hyde, because it has its advantages and disadvantages. And what are those? So basically, the ecosystem is amazing, right? Because we have so much variety of software that we can pick. And it's almost all typically open source or with open source versions. And we just go there to this repository, compile it, install, deploy it, and we are done. Well, of course, configure, whatever. And there's a lot of variety, and there's tools in almost every category with many different options. So that's great. Now, ask, and we have faced this so many times with our customers, as a non-super experienced user, what do they think about this ecosystem? They're lost. They don't know what to pick. So there's 7 tools for HA. Which one is the good one? Why you have 7, right? Why not just one that is good enough? Well, maybe that's impossible. Maybe we can have different compromises, but for users, this is very confusing. They don't know which one to pick. They don't know what to do next. They don't know how to configure them. And each one has its own criteria, its own standards, its own way of doing things. And it becomes very difficult for users, not only to pick which solution is the correct one, but also how to tune them, how to configure, how to make them work together. And admittedly, not all of the solutions in the ecosystem are good enough for production use or for performance or both. So you also need to be very careful. And we've seen problems by not making the right decisions. And so, you know, it requires a lot of expertise. So it's very good because of the variety, but also requires a lot of expertise. So let's discuss in more detail this problem. So what do you need if you want to deploy an enterprise-grade Postgres stack? In my opinion, you need a set of components similar to the one that I'm showing in the screen. So you need, first of all, you need configuration. You need configuration tuning. This is critical to run Postgres. You need connection pooling. It's very hard to run a Postgres in production without connection pooling in front. It has many problems. You need high availability. Times are over when you say that you prefer, you know, to wake up 3 a.m. to fix a cluster that is failing. Most of the cases require automatic failovers. Obviously, you need backups, and no, I'm not talking about PG dumps, right? I'm talking about continuous archiving in Postgres and solutions for doing these backups. You also need to maybe to work on logging. Not only configuration, there's more than 40 parameters for configuring logging in Postgres, but about a concept I'll also introduce later, which is distributed logging. You may also require a product Postgres that may, oh, hold on just a moment, I think there's an issue here. Is sound still okay?
No, it's like much worse.
Yeah, hold on. Just by some reason, I saw a message that the sound switched to a different one.
Yeah, it's been like strange sound, like, and now it just sounds like change.
Okay, is that okay now?
Yeah, it's better, yes.
All right, sorry about that.
No problem.
Okay, so back to where we were. Oh, hold on, it's here, presentation. Excellent. So let's move forward on this side. Okay, so these are the components that require enterprise-grade stack, right? So let's look at them in turn. So first of all, configuration. As I said, Postgres needs to be tuned properly for deployment into production. This requires operating system tuning, file system tuning, but specifically Postgres configuration. This is a topic that I love personally. I've made a talk about this called Postgres configuration for humans. You can have the link here. And this is a very successful talk. A lot of people have been watching this talk and enjoying the slides. And there's another project that we created at my company called PostgreSQL.nf, which, yes, it is like the PostgreSQL.conf file, except that shifting the dot 2 positions to the right. And if you're not aware of this project, is a website where you can check all the parameters, all the documentation for Postgres for all the different versions, with including some hints on how to tune it. And this is also translated in several languages. So there's a lot of work to do there, a lot of stuff. You can go and check it. But this is, again, one of the parts that you need to do for Postgres deployment to production. Then you also need connection pooling. I'm not going to go into this topic because it's very long, but basically, when you don't put a connection pool in front of Postgres, you may end up with performance that looks okay if you look at transactions per second, like you can see in this graph, but where the latency will grow exponentially if you're overwhelming the server. this is what happens without connection pooling. Actually, your performance may look like it's okay, but it's not okay. Your users are experiencing a huge latency, which is unacceptable. So you typically want to have a connection pooler in Postgres, right? But which one? Because there's pgpool, there's pgbouncer, there's Odyssey. So there's typically 3 options here, and which one is the best one? And actually, where do I place this pool? Do I do it on the client? Do I do it as a middleware server? Do I do it just in front of Postgres? Or any combination of those? And there's no possibly right answer for those. I would say that, oh my God. Same happened again. So sorry about this. Okay, I think we're back. Hope it will not happen again. So we have several options here, and one of them needs to be the best one, and you know it's complicated for the non-Postgres expert to solve this problem. Okay, what about high availability? We're having again a lot of options here to choose from. So we have pgpool, we have Red Manager, Patroni. You can see the slides, right? There's so many options, and which one is the best one? Which one should I pick? And I really typically need one, right? So there's many options and many compromises, and this is not an easy answer. Same with backups. As I said, pgdump is not an option because pgdump just represents a logical backup on a given instant of time. So it's not enough for our needs. It doesn't guarantee basically data loss. So we need to use tools for backups that are based on continuous archiving. And there's again like 4 or 5 choices. And where do I, by the way, store the backups? There's several options there also. So again, it requires a lot of work here. About logging, just imagine you have a cluster, you have a customer with a 12-node cluster, 12 nodes, right? So once you are trying to trace a problem of a query that maybe started on a master, and then there was a, you need to check effects or problems on the replicas, you basically end up SSH in, all day to all the nodes, and 12 nodes is a lot of nodes, right? So, we believe, and especially in a cloud-native world, that you should go for centralized logging, which is basically, let's extract the logs from all the servers and push them to a central location where we can analyze them and parse them and generate reports from there and see them in a centralized manner. There are some cloud-native solutions for this, but especially being on the Postgres world, our favorite solution, and I'll talk this a little bit at the end of the presentation today, is about storing them on Postgres with the timescales extension. So we analyze the logs in SQL, which is very cool. And about the proxying, actually, solving the HA problem, the high availability, is not easy because you always need to solve a problem called the entry point. The entry point is, how do I locate in a stable manner my master node? Because if the master fails, a new one will be elected, that's cool, but how do my application node knows that the master has changed, right? And then there's a variety of options here. You can use virtual IPs, you can use DNS, you can use load balancers, you can use many other tools, right? You can use HA proxies. So there's many options there also. This is the entry point problem. And one good option to solve this problem is to put a proxy in front of all the Postgres nodes. And then this proxy will be reconfigured dynamically when the master changes, and probably talk to the DNS system and expose this as a single DNS entry where the application, which is stable. And you may also use this to, for example, offload the SSL, the TLS connection, because proxies are typically more efficient than Postgres for doing this. Last but not least, we need to monitor. And well, there's tons of tools to monitor Postgres on services. Which one to pick? Same story. And finally, some people want an UI to manage all the clusters. And again, there's many tools for these, many options. So all in all, we need a lot of tools around Postgres to really deploy it into production. And this is what I was saying, that typically will require an effort of a Postgres expert of several weeks.
especially if you want to do this all automated using infrastructure as code and best practices and security practices. And depending on different environments, you may get different results. It's not totally reproducible process and takes a lot of weeks. This is what happened to us. We've been doing all this work for years, and it takes a lot of time from experts on doing this. So can we do this a little bit simpler? Can we package somehow this distribution and really create this Postgres distribution with all those components? This is the question I want to answer today. And obviously, once we have this, where do we deploy it? We can go clouds, we can go on-prem, and then obviously the environments, the way we prepare this distribution, these components, this stack, it's going to be totally different. So even if we now do this for one environment and we switch to the next one, everything is going to change. So it's a tough problem, really. So how do we deploy a Postgres stack on Kubernetes? So let me make a really brief introduction about Kubernetes. I call it the JVM of distributed systems. And this might be a really bad definition, but I wanted to say here is that in reality, Kubernetes is just an API that abstracts us away from the underlying infrastructure. So by hiding everything behind this API, as long as I'm able to program against this API, I don't care about what is the underlying infrastructure. It is the responsibility of the infrastructure team that has deployed this Kubernetes cluster to understand how they're wiring the network, the storage, and all the components. I don't care. As long as I'm able to program against this API, I can create a program, a Kubernetes program, Kubernetes deployment that will run on almost any Kubernetes compliant environment. And that's why it's similar to JVM. JVM, you don't care whether you're running on Linux or Windows, Solaris, whatever. You just create your program and run it on any JVM. And that's not a problem. So what is this Kubernetes API does? So this Kubernetes API is very good because it brings you APIs for IP discovery, for managing secrets. It's a great way of managing credentials, for network connections, for load balancing, for storage. There's a lot of huge set of APIs that Kubernetes is providing that allows us to define this infrastructure in an abstract way, which is the API of Kubernetes. So with all this, we can actually automate a Postgres deployment. Because now this problem of which environment, which cloud we're deploying to, we no longer care. We just need to deploy on top of Kubernetes, and that Kubernetes could run anywhere, could run on any cloud, could run on-prem, but we can deploy the same stuff. So once we do this, once we switch to Kubernetes, we can really automate, fully automate a Postgres deployment with all these components that I mentioned before. Because now we don't depend on the huge variability of different environments. And there is a thing called operators in Kubernetes. And basically an operator, it's a pattern, it's a way of doing things in Kubernetes that is composed of two separate parts. One, it's what it's called a CRD, or custom resource definition. It's something I'm gonna speak a lot today. And it's just extending the Kubernetes API with custom components. For example, if we're talking about Postgres, we could create a CRD to represent the Postgres cluster. And this could actually expose very high-level interfaces to this Postgres cluster concept. And you just need to code against this API to create your Postgres cluster, which could become very, very simple stuff, hiding all the details, all the complexity behind the scenes. And the other part is a program called the operator or the controller that actually acts when this CRD, this custom resource definition, is either created or updated or deleted. And then it will take actions to actually transform this definition, this API call, let's call it that way, into the actual resources that need to be created. So if, for example, if me as a user, I am provided the system when there's a CRD to create Postgres clusters, I will fill in the details like the number of instances that I want, the size of the instance, of the disk, whatever. And then when I say a Kubernetes apply this API change, that will go to the controller, and the controller will actually do all the magic behind to actually create this cluster. And also operators can encode business logic. So operators can automate things. And in the future, we're gonna follow this way, of course, that operations that are more or less automatable, the DBAs do all day, like repacking, reindexing, all this can be automated and encoded into the controller part. And then it could be run automatically for you, or just say, hey, I want to repack this table, and it will do it for you. You don't need to type any Postgres command there. You don't even need to know how that works. So it's a very, very powerful pattern, which we're leveraging here. So what is cloud native? Because this belongs to the title of this presentation. So let's understand first what it is. There's no standard definition. My take on this is that cloud native applications are something that is containerized, so in other words, that is designed to be run on containers, and that takes concepts like scaling and high availability as a totally native concept, something that you really need to do. And it also follows best practices in terms of container design. How do you package a container, having a single hierarchy per container, and to split aspect workloads, separate workloads into sidecars. I'll also talk about this. So the first thing, containers are not slim VMs. A lot of people say, oh, you know what? I've got a VM, so I'm just gonna shrink it into a container and I'm good, I'm cloud native. Well, not really. First of all, a container is not a VM. A container, and this is very important, is just a light wrapper around the process. It's a wrapper that may abstracts actually the network space. So you see like a totally IP network and port space for your container or pod in Kubernetes. It abstracts you potentially the file system. You might see a virtual file system, and also the process space. You may see your own process only, if you were executing alone in the host. But in reality, you're just in the same host as everybody. There's no virtualization there. That means also there's almost no overhead in terms of performance. But then it becomes a bad pattern to include like an init system on a container to launch many processes. You should only launch a hierarchy of processes, a master process that runs others. The reason is that a container dies if your process dies. If you have several ones, your container may not die when one of those processes dies. And Kubernetes is designed for failure and is designed to restart and reallocate your containers if some of them dies. But without following this approach, you're not following security best practices, you're loading containers, and you may not have the high availability that cloud native applications, as I mentioned just before, are expected to have. So with all this in mind, how do we take a Postgres and make it into a cloud native application? First of all, just very briefly, there's some concerns sometimes about performance. There's been a lot of discussion about this, but the performance overhead of running containers is minimal as long as you use external volumes like persistent volumes. So that should not be a concern. As I mentioned also before, you need to create minimal container images. So it's not only about the disk space that these container images may use, but also about security. The less binaries I have there, the less security surface I'm exposed to, right? So basically remove anything that is non-essential for running a container. A container is just a process. So I don't need the manual pages. I don't need example config files. I don't need libraries that are unused. I don't need a whole OS. And definitely I don't need any component that is not strictly required for this binary or other binaries. For example, in case of Postgres, to run a Postgres container, I don't even need PSQL. We might discuss that you want PSQL for administration, but not to run the container itself, right? So you can really strip down, and you should strip down containers. And then, okay, use this sidecar pattern. So the sidecar is as I mentioned just on the Q&A session just before the talk, in Kubernetes lingo, Kubernetes world, there is pods, and that's the unit of work that you schedule. And within a pod, you could have one or more containers. One pattern is to have like your main container, which in Postgres world is going to be Postgres, and then have other containers which have their own different images, which might collaborate together because they can share part of these namespaces. For example, they share the IP namespace, but they can also share their file system namespace. And so they can see kind of the same file systems. And you can implement this sidecar functionality there. For example, if you need tools for administering a Postgres container, you can run it as a sidecar. Actually started with Kubernetes 1.17, if I recall correctly, or 16, there's support for ephemeral containers, which you can only run them whenever you want dynamically. and you don't need to have all these binaries loaded into disk or memory if you don't need to administer the cluster in the classical way. And so with these sidecars, and I will explain the sidecars that we have later, you can separate functionality into different components. You follow a component approach or a divide and conquer approach, which is always recommended. How do you do HA, high availability? This is an interesting question because Kubernetes provides primitives for high availability. Kubernetes runs a etcd service on behind the scenes, which is a distributed consensus service, which allows you to get a consistent view. And this is a component typically used by high availability itself. And Kubernetes uses this, leverages this to expose high-level primitives for HA. However, these primitives for HA are not strictly designed for stateful components. And they will act a new leader, for example, but they will not be aware, for example, of the replication lag, which is typically not what you want with Postgres, right? So there's better tools. There's great tools for Postgres high availability, like Patroni, for example, which we use in the software I'm going to describe. And you can just leverage them, and they run well on Kubernetes. So in this case, the key is to ignore, not use Kubernetes APIs for HA. They're good for stateless applications. They're not that good for stateful, and rather use Postgres native tools for HA, like, again, as I said, Patroni. And as I mentioned already, centralized logging. The idea is to capture the logs that happen on a pod, send them outside to a central location, and process them. I'll show you, talk a little bit about this. So let's talk about the software, which we have written, which is called StackGres. This open source software, and basically tries to bring all these capabilities and all these options and all these best practices that I have just described up to now into an existing software that is available right now. So StackGres is what we will call cloud native Postgres. It is a set of components packed to run on Kubernetes. So this could run on any cloud or including on-premise. It is designed to be enterprise grade, which means it is ready to run any production workload. And for this, we solve the ecosystem problem by doing a highly opinionated stack. We, based on our many years of experience in working with enterprise customers and deploying Postgres stacks, we believe we have a pretty good idea of what are the best components out there in the Postgres ecosystem and how to tune them and how to pack them to work together. But this is open source, so if you have a better idea, you disagree with some of our choices, just file an issue on our source code and tracking the repository and GitLab, and we will discuss there. But we try to only present you one option, which actually we don't even want you to know about it. So for example, for HA, we use Patroni, but you should not know about that. It works automatically for you. And this, if we look at it from the perspective, this is like a database as a service, like a Postgres as a service, like you can get on any cloud, except that you can run it on your own environment and you get super user permissions. So you get all the automation and all the benefits of a full-blown DBA database as a service solution, except that you can run it everywhere, and it's open source. So what is the architecture? There are several layers of the architecture. The first one is the pod. And as I was saying before, in the pod, we have a main container and then several sidecars. And this is exactly the example. By using this Kubernetes feature, which is called shared process namespace, then we are able to communicate these containers that are running along the same pod. So we have the main container, which has Postgres and Patroni, which we can see here. Postgres and Patroni, they're two components, but they're part of the same hierarchy. Patroni actually starts Postgres and runs Postgres. And then this spans a single hierarchy and all the processes that are spun up by Postgres, but it's a single hierarchy that is rooted by Patroni. But then we have all these sidecars. We have this Postgres util container, which contains tools for Postgres administration, but they're separate to separate container. This only has the Postgres binary and associated libraries. The same with connection pooling, where we're using PG Bouncer, which is again another sidecar, and this goes back to your question at the beginning, that they can talk together via this shared process namespace true and using Unix domain sockets for maximum performance. We also have Envoy. This is to solve the entry point where we have this Envoy, the open source proxy, which is able to actually route and reconfigure the entry point for Postgres, and will play a significant role in future developments of StackGres. We also include a logging forwarder component and agent to forward the logs to a central location, as I was discussing before, and also another sidecar for exporting the metrics to Prometheus. So as you can see, it's pretty loaded set of components already, just for a pod. And pod, we're going to have one pod per instance of a cluster, right? So this is multiplied by 2, 3, 5, whatever number of instances you have in your cluster. When we look from a cluster perspective, we're going to have several pods, as I was mentioning. One is going to be a leader pod, and there's going to be potentially several replicas pods. We expose 2 connections, which are exposed on Kubernetes via DNS to connect. One is going to be a read-write connection, which goes always to the leader pod, whatever that one is, and a read-only connection, which is load balanced across the rest of the replicas. So you can, from your application, they're exposed via standard Kubernetes DNS, so you can connect to either of these 2 connections, and you will connect to the appropriate pod or pods. And well, this is a pod, and this is how it is related to the storage. But I have a specific representation of this. So the way storage works is actually pretty simple. We ask for a persistent volume from the storage pool, from this storage class, per pod. So Postgres will store data always on external disks, so the persistent volumes, which are handled by a persistent volume claim, which is a handle that we actually request for having a persistent volume to be created by Kubernetes. And so it's based on the template that belongs to the definition of the pod. This is created by StackGres, so you don't need to worry about that. Just specify what is the storage class that you want and the size that you want. I'm going to show you all examples of all this. And finally, interesting is the networking, how it works. So for the networking part, we have the Envoy proxy, which is again proxying all connections to all the pods. And it's exposing the port 5432, the standard Postgres port for connections from applications. And also the replication port, which is obviously, which we use for 5433, which is obviously required for all the nodes to replicate from here. Now, PG Bouncer, which by the way is optional, you can activate or do not. If it's running, it's going to be running on port 5434, and then Envoy proxy is going to proxy to PG Bouncer, and then PG Bouncer is obviously going to run proxy to Postgres, which is running on port 5435. If this would be optional, Envoy will directly connect to Postgres. The replication protocol cannot be proxied by PG Bouncer, so it goes directly to Postgres. Sounds a little bit complex, but for the user, this is all transparent. The only thing that you need to know is that Postgres is exposed to applications on 5432. So, how do I deploy a Postgres cluster, a Postgres as a service with StackGres? If all this has been packaged as I've been described, and all this stack of components already prepared for me, because it sounds too complex to me. Now, what do we want with this, and how you as a user would do this? And the idea is that we have tried to make this extremely simple. One of our goals is that Postgres, I don't know if you have checked or know this project and set of documentation by Kelsey Hightower that basically is called Kubernetes the hard way, right? So pretty much by also using the same idea here, we would say what we have seen so far is Postgres the hard way, right? It takes a huge amount of effort to do all this. Now, can we make it so simple that users, even without a huge understanding of Postgres, even users that barely know how to run a Postgres cluster can create an enterprise-grade professional solution for their enterprise workloads? This is our goal, to make it very, very simple to do this. So how is it possible to do this? Well, remember that I mentioned that operator pattern in Kubernetes is CRDs plus the controller. We've written the controller, and we expose several CRDs, and this is our API. So to deploy StackGres cluster, you don't need to install any command line interface or any separate tool or any complex thing. Just use standard Kubernetes tools, command line tools, and I'll also show a graphical way of doing this, and you're good to go. If you know Kubernetes, now you know StackGres, and you know Postgres, consequently. You can deploy a full stack with this. So these CRDs, custom resource definitions, are the definition or the API that the StackGres is exposing to you. Learn this API, which is pretty simple, by the way. I'm going to show you, and you're able to create StackGres clusters without a problem. And now, whenever you instantiate a CRD, that's called a CR, a custom resource, right? So you can create as many custom resource, and as long as you comply with this definition, with this CRD, StackGres will do all the hard work and will wear all the details behind the scenes to create all these components, all these clusters for you. So the way we have designed these CRDs is very high level. They on purpose are made easy to use, and on purpose are hiding all the details, even about the technologies we're using underneath whenever possible. So you should not know that you're using Patroni. You should not know that you're using OLG for backups. You should just be able to express your Postgres desires in a really high level, and we'll take care, StackGres will take care of all the details behind the scenes. So no need to install any command line or graphical tool or anything. Just standard Kubernetes tools and YAML files or web UI, I'll show you later, are enough to create clusters with Postgres in StackGres. Last but not least, we also use these CRDs for bidirectional communication. In Kubernetes, the custom resource definitions, or any object for that matter, have a field which is called the spec. That's the definitions. That's the fields that you need to fill in order to communicate the actions you want to take to StackGres. But we also use a status field to provide feedback to you, to provide information back to the user. So, for example, StackGres automatically supports the functionality of creating automated backups, right? And whenever we create a backup, we create another CRD for you. And sorry, a CR. And by inspecting this CR, you may see a lot of information about this backup, when it was created, what is the LSN there, what is the system identifier, and many other data about this backup that was created automatically for you. So we use for bidirectional communication, specifically to convey status information. So let's turn this practical. How does it look like? So Kubernetes is all mostly about YAML, and this is the basic YAML to create a cluster in StackGres. So you just specify the API version, which is now this one. You specify the kind of object you want to create. So we have a CRD for StackGres clusters, which is named this way. The name of the cluster you want to create, and then this spec that I was referring to. Which Postgres version I want to use? Latest. Okay, sounds good. The number of instances too. This means that there will be one master instance and one replica. And then for the pods, in particular for the persistent volumes, what size do I want? This one, 10 gigabytes. And that's it. As you see, we don't need to talk about high availability or connection pooling or Envoy or Prometheus or anything like that. All this will be done automatically for you. Actually, what this will create, and we're going to show this if demo works, demos, is create a cluster that will include Postgres, Patroni, all automatically configured, replication to instances. They will contain a PG bouncer. They will contain a default Postgres configuration, a default PG bouncer configuration. They will have Envoy proxying all the traffic for you, and if there's a Prometheus connected, they will also start exporting vectors to Prometheus. And all this with 10 lines of YAML. That's all you need. And you don't need to be a Postgres expert to do this. Now, let's make it a little bit more complicated, or not necessarily complicated, but more powerful, right? So apart from this, one of the keys about StackGres is that we have tried to bring all of our expertise and all of our best practices into this. And so there are other CRDs, other definitions that we believe are best practices. For example, for us, a best practice is not to define the size of an instance on is that okay with audio? Okay. So it's not all about having on a per instance definition per cluster. So if I want to create a cluster, I'll say, okay, it's going to be 2 cores and 4 gigabytes of RAM, whatever. But on some big companies which we work with, the size of an instance may need to be approved by a department, a different department, right? So we believe a better approach to this is to create a approved set of instances and assign them a name. And this is what we call an instance profile. So for example, you can create instance profiles with as few as these amounts of YAML code, and you give them a name. And so you say, oh, small instances, size of small instances, have 2 cores and 4 gigabytes of RAM. And that's all you need to create this concept of an instance profile. And now we will see that when we can create a cluster, instead of relying on a default size, we just specify a name, and that will create the instances based on this size, this sizing. This helps you to keep more homogeneous workloads. This is also very good for resource adoption and for resource control. And maybe in the future, we'll provide granularity. So maybe all the instance profiles can be created by administrators or with higher level privileges. And then you also can only select it from predefined instance sizes. So this is a best practice that we're trying to enforce here. But also, you may want to specify your own Postgres config, obviously, right? I was talking a lot about tuning. StackGres comes with its default tuning, but obviously you should have the ability to deploy your own Postgres configuration. Oh, how do you do this? You go inside of the container and edit PostgreSQL.conf file, right? No. First of all, that's ephemeral. Second, it's running on Patroni, and Patroni handles the Postgres configuration for you. Oh, Patroni, how do I touch this? We don't want users to mess with this. It's enough to understand how to tune Postgres parameters, which is already hard enough, right? So we expose this as another CRD, and you may create CRs, instances of this CRD, as simple as a YAML like this. Just specify the API version, which is the same, the kind of object, which is called SG Postgres config, StackGres Postgres config, give it a name, and specify the Postgres version and the parameters for the Postgres config file that you want to put in there. It's as simple as this. And now I'm going to show you in a demo how to actually create these resources. The same with the connection pooling config. Now we're using PG Bouncer. In the future, this may change, but just create a CRD like this, a CR instance like this with this tiny YAML file, and you can pass your own parameters to the PG Bouncer that is going to be created as part of every Postgres pod that is going to be created by StackGres. Now, one really cool feature about StackGres is that it creates automatic backups for you. You don't need to do anything. Automatic backups will be created for you. But for this, you need a little bit of configuration. So the first thing, and here's an example by storing backups in S3 on Amazon, you need to create some credentials to access this S3 packet, right? So in Kubernetes, this is not a StackGres, but in Kubernetes, there is a secret, and which is a bit of information where you can store things like passwords, right? So for example, here I specify one that is called AWS Create Secret, which has 2 keys, which I decided to call access key and secret key, which contains values. Don't worry, this is not this random stuff that could be the credentials, right? And now I can finally create what we call the StackGres backup config, which is yet another YAML file I can create and specify with a huge amount of details how I want these automatic backups to be taken from me. For example, I can specify that the base backups, I want them to run on a cron schedule, which is this cron spec. This one would mean every 2 minutes. And I want to keep on a sliding window 6 of them. So not only we're taking automatic backups, we're also purging all backups based on this criteria. And then let's say I want to store them on Amazon S3. Then I provide some detailed configuration for S3, which includes the name of the backups and then the credentials. And for the credentials, I'm just using a standard Kubernetes object, which is called the secret key selector, where I specify basically the name and the key. This is the name of the secret I created before, and these are the 2 keys that I created on the secret before. This is the name, and these are the names of the keys that I'm using here. And if I create all these, let's say I create an instance profile for this instance sizing, I create a Postgres config, I create a pooling config, and I create a backup config, then now I can create a cluster that use all this. And this is like a much more pro version of a cluster. And then I go again with the cluster, I assign different name, and here I specify the instance profile that I want to use. I can also specify the storage class that I didn't specify before. And finally, I specify all the configurations that I want this custom cluster to be using. This Postgres config, this pooling config, and this backup config. By the way, this also means that the Postgres configurations, the connection pooling configurations, and the backup configurations, I can reuse them. Think of them Postgres terms foreign keys, right? I'm just putting a foreign key here to a given Postgres config, to a connection pooling config, to a backup configuration, to an instance profile, and this can be reused across instances. And this will obviously create a cluster with all these configurations that I mentioned. And the last example that I want to show here is that also StackGres supports creating a cluster that instead of being empty, it will be restored from an existing backup. So if I create this other YAML file, and here I set this part to is called initial data, and I say restore from a backup, and I pass the UID of a backup that has been either manually or automatically created. And when you inspect the backup, you'll be able to see this UID. Just put it there, and it will create a cluster. It will be restored from this backup, and will show you the data that was there in this backup. So let's make a small demo out of it. If you want to run this demo yourself, right now, if you go to the StackGres website, which is stackgres.io, you'll find the current version 0.8. Now, we wanted to show a lot of cool stuff that's coming in 0.9. So I'm going to run the demo based on this version, 0.9 alpha 1. It is so just out of the oven that it's been released today. And it has a small edges, being an alpha version, but I prefer to run the demo on this version. So let's give it a try. Very likely will fail everywhere, but it doesn't matter. And this is the only command that you need to run to install StackGres. So if you have a Kubernetes cluster, run this command, single command, StackGres is installed. Let's see if it works. So can you see the screen? Let me just make sure that it's shared. Okay, can anyone confirm if you can see?
Yeah.
Okay, font size is okay for everybody?
I think it's pretty big.
Okay, excellent. So first of all, let's download this file. Actually, well, this is the URL that I was showing you before. I have the file, it's just a wget, but I have downloaded it here. For these demo purposes, I just need to do a, well, let's actually do this. So let's download this file. Oh, sorry about that. Let's download this file. And I just need to do a small edit here because, no, I think this might work. So if this works directly, then it's just this last minute changes. So I'm going to try to actually run that command directly. So I do kubectl apply this f. Kubectl is a standard Kubernetes command. And I'm just going to say, hey, you know what? Go to this URL, download it, and create whatever is there. So this single command will install StackGres. This creates a lot of stuff. I don't need to worry about this, but you can see here that there's some custom resource definitions that I was telling you about. We can see the names that actually we were discussing before. Creates a lot of stuff here. I don't really need to worry about this, but the cool thing is that StackGres is already installed. This, by the way, I'm sorry, did I mention before? I'm using an Amazon cluster on it, I'm using EKS service. I didn't show it was empty. I promise. I forgot to do that. I promise it was empty. It was just barely created right now, and so I don't need to install anything special. Just run this command. You can try this at home, and again, StackGres will be installed. So if everything is good, it's going well, I should be able to check the StackGres namespace, and let's see if there's any pod there. All right, it looks good and looks like the StackGres is running. So if it's running correctly, I should be able to start creating clusters. So let's go here, where I have basically the copy of the YAML files I was showing to you. So for example, here we have this cluster. And this is the basic example that I referred to you before. And because I'm actually running a little bit out of time, instead of creating this one, I'm going to try to create a more advanced one. But create any of these files is just called kubectl apply f and then the YAML file. So the first I'm gonna run is this to create an instance profile. Super simple stuff. So I can refer this name to an instance profile later on. So let's just kubectl apply. This is very fast, and it will create this this instance profile. Next one, I'm gonna check the Postgres config. So I'm just gonna create a random, nothing special, not super tuned, just for example purposes, Postgres configuration here, which I'm gonna call pgconfig1, which I will later use on the cluster I'm gonna create. So let's apply this and create it. By the way, if I would have run this directly, kubectl apply this one, the cluster one, I will already have a cluster. But let's go for the full-blown example. The same I will do with the connection pool config. I will just apply it and I will show it later. So this just has some commands for PG bouncer configuration, pretty simple stuff, and it's also created. Now I'm gonna create the secret, which contains the credential for the Amazon S3 bucket. This one I just placed on a separate place so I can show you one without the credentials. But this is a real one, so I'm gonna create this one. And now I'm going to show you the one with the credentials removed, just because I don't want to share the secrets with you. Sorry about that. And here's the real meat, right? Here and here. Once I have created this secret, I can create also the backup config. It's going to be here. I create this backup config, and now I'll show you the file. It's the one, again, I showed you in the screen before. So I specified it's going to take a backup every 2 minutes, the retention period. On S3 bucket, and we're using this Amazon credentials that I created on this secret called this. And this should be created. So now I'm ready to create a cluster. So how the cluster, well, let's create the cluster first. This is a cluster 2. And this is a cluster I'm trying to create. So I'm going to try to create a cluster here with Postgres 12.2. That is going to have 2 instances of this type, which is size small. And they're going to use 10 gigabytes PG data based on this performance credit-based storage on Amazon, using this Postgres config, this connection pooling config, and this automatic backups config configuration that I just created before. Let's have a look. Okay, there we go. So we have the first instance being created, and soon there will be another one. Yep. So we have already the second instance is being created, and will be ready very soon. And we have also the backup system already running there. We don't need to care much about this. So how do I demonstrate that there's a Postgres actually here running? So by looking at the pods, actually, I see that they have this. These are the names of the pods that are being generated. This one is running right now, but this one I can also already connect, for example. So I can use a kubectl exec command. So let's select the pod name, and I'm going to connect not to the main Postgres container, but this Postgres util container. As you remember, we're using this Sidecar, and this Postgres util contains PSQL. So if I'm able to type, okay, sorry about that, this correctly, I can say PSQL because I'm going to connect to the container itself. This is just a quick way of doing this because I haven't created a new user, and it runs on this port. So by using this command, I should be able to connect to Postgres. And yeah, here I am. This is a Postgres 12.2, and here I can see this. Now, I can also connect and run another command. I can connect to the Patroni container and execute the command Patroni. This is just for your for showing purposes that is able from Patroni to list the state of the cluster. And here I can see that I have indeed a cluster of 2 nodes, where this one, which contains the main first pod, is the leader running, and you know it's already running. So what I got here is that I'm having a Postgres container here, and you know, by the way, we can show here that these parameters was max connections that was edited here has been also applied, and so forth, right? So what we have done here is that we have created with this configuration tune config, connection pooling, Postgres cluster with 2 members, automatic backups, so forth. Now, we can do really cool things with this Kubernetes style. For example, let's say I want a 3rd instance. I just need to edit this file and kubectl apply. Sorry, this. And that's it. And this will start creating very soon a new instance. The 3rd instance for this. Okay, interesting. There's an error there, but it will be retried soon. So this one is being created. Now, this is all about YAMLs. Now, is there also a more user-friendly UI way of configuring this? And the answer is yes. StackGres also comes with a UI. For now, I just need to run a small command to run this. This is going to be included in the distribution of the final version, 0.9. And this is this command, so this command will not be necessary, but this is going to create a load balancer, as you can see here. And this load balancer, it takes a while to deploy. So, but this, I will check this later, but this load balancer will expose a web UI for StackGres, and we'll show the cluster that I've created, and I can create everything from the UI. Let me actually share a development version of this while the first one is being created that I have here for you. Actually, let me just try if this one works already. This is Amazon creating the load balancer. I think that's something that, yeah, it's not created yet. But I can show you while it creates. I can show you because we're running a little bit tight on time, I think. Yep, so here I have this UI. I hope the font size is okay, where you can see everything that we have been doing with command line, but you can do the same with, with a UI. So here's an existing cluster, and you can edit here any property. You can see here the instance profiles. You get a lot of help from here about which components. There's a lot of advanced options that I even didn't mention about configurations and so forth. You can create new ones. You can list all the configurations, for example, Postgres configurations, and I can check to see the details of this configuration, which contains all these parameters. Same with connection pooling, and the same configuration about the backups. And I can see here how this is configured. This is a cron. I can see all the details, obviously, except the passwords are exposed here. And I can definitely, edit any configuration, create a new backup configuration. And again, there's even included help here where I can see all the information about how to specify every of these fields. And if I select more advanced options, I can see I can specify also compression methods and about storage. For example, if I select Amazon storage and I go to advanced options, I can specify also paths, the regions, and even infrequent access storage class for the backup. So this also you can do obviously all from the CRD. From the command line interface, but you can see from this web interface. Same with instance profiles. And by the way, if I go to a given cluster, I can see all the information about this cluster, and I can click on this, and I see a drill down of the pods that are contained here, the status of its pods, the health system. I can see the configuration that is being used to create this cluster, and if there is a Prometheus service, I can see Grafana dashboards about how this performance is going on this server. Right? And also, last but not least, I can also see the backups that are running that have been created. Like for example, right now we had the luck to see a backup starting to be created and backups that are completed. And I can see more information about the given backup. What is the LSN where it started? The UID that I was mentioning before I can use to restore a backup, and the compressed size of the backup, and some information that will be displayed there. About this UI, two really cool things that I wanted to finish this talk with. First one is that, yes, there is a dark mode. It's very cool, right? Light and dark, also for people with different sensitivities and different vision capabilities. And as a small Easter egg and preview, if I have this option show logs, it has a preview of what it's going to look like, our centralized log functionality, which is here is the page where you'll be able to see all the logs as they are forwarded from all the pods into a central Postgres database, which is running on top of Timescale DB, which will be able to filter all the logs, and you can access them by SQL queries or via this web interface where you can search. This would be logs and backup, but it's on development, and filters and select visible columns and all this. So this is what I wanted to show, the quick demo about the creation of clusters, the CRDs, the web UI, and that's pretty much it on my side. I know we're a little bit close to the end of the allotted time, but I'm happy to take any further questions. This is the website. Go and check StackGres.io, and if you want to participate, we're doing all development in the public. It's on GitLab. You can create issues, you can drop comments, you can participate, you can send merge requests, all that. So I'll stop sharing screen.
Okay, so I still like the first question. Does it support GCP?
Yes, so we support theoretically everything that runs Kubernetes. We're deeply testing in Amazon, Google Cloud, Azure. We're starting testing on OpenShift, and we test on other minimal containers like Minikube, MicroK8s, and Kind. But more are coming, and more deeper testing are coming for all environments. It should work. So if you want to give it a try, go to Google Cloud, and yeah, absolutely. Any Kubernetes compliant environment. For now, we require 1.12. We're going to lower this bar probably to 1.11 to support OpenShift. But that's it.
Okay.
If it doesn't work well for you, let us know. The back report on GitLab.
Okay, there is another one. Can you download the backup from this UI, and can you start restore from given backup from the UI?
Okay, the first question is no. You cannot download the backup from the UI because this is not a logical backup. It's a physical backup, right? So it's going to be a base backup. While you can restore from a base backup, typically you want the base backup plus all the WAL files together that are also part of this base backup until the next backup, right? That is the theory behind continuous archiving. Now, you're selecting the bucket you're sending this backup to. So in this case, with the cluster I configured, the backups are going to S3. So you can go to S3 and download the backup from there. It's yours. This is the main difference between StackGres and managed cloud solutions, because managed cloud solutions is very opaque. Here, it's totally open. You're selecting where you want to store the backup. So go to S3 and get the backups. But you'll probably want to get the base backup plus the WAL files.
Okay, there's a question from Alexi. Do you manage Postgres configuration directly, writing PostgresConf, or by using the Patroni API?
So right now, we're just writing the configuration. So Patroni is managing the configuration. By the way, Alexi has a significant impact in Patroni. So Patroni handles the configuration for us. We just pass the configuration to Patroni. Patroni handles it. But we are not doing this via the API, except for reloads. But on the next version, we are planning to develop a pod local controller that will interact directly with Patroni API for certain operations like reloading the config and so forth. But we're leveraging Patroni a lot.
And how do you cope with node restarts during cluster upgrades?
All right, so this is an item that is open for the next version. So it's not done right now, the way of restart the nodes. Now, the way we're gonna solve this problem is by exposing yet another CRD that is able to specify, hey, I want to restart the cluster. And restarting the cluster is not easy because you don't want to shut down connections. I mean, if you're willing to take downtime, that's okay. It's pretty simple stuff. We can just, actually, you can just kill the cluster. Kill all the nodes, but and Kubernetes will bring them back, all of them. The storage is going to be there because they're external persistent volumes, and you're going to be good with that. But doing a more controlled approach is what we want to do for this 1.0 final version of StackGres that will contain this restart code, and will handle restarts gracefully, step by step, and doing a control failover at the last stage. Okay,
so another one, have you tested updates also with Qt? He means Kubernetes updates?
No, this is again something that is pending for the 1.0 final release. However, Kubernetes upgrades and as well as the operator upgrades, this thing that those can be also disruptive, but in general, we're talking about the control plane, right? And the control plane is something that is low bandwidth and could be even, not totally available at the time. So the StackGres controller, which is running all the magic behind the scenes, it's only needed when you perform actions against it or something fails, right? So it can have smaller periods of downtime, but yes, it's also part of it.
You used latest as Postgres version. How do you deal with major Postgres upgrades? Thanks for the great presentation.
Thank you. So you can use actually if I go back to the I stopped sharing my screen, but I can do that again. If you go back to the web UI, by the way, this should work now. Forgot to show this. Yes, this is a self-signed certificate. So this is the one that I created automatically by exposing this. That's correct. Yes. I'll switch to this mode. I like it a little bit more. By the way, you see, this is the one that we exposed automatically. So this is the SGCluster that we created. When I create a new cluster, for example, let's do it right now. I can select here a Postgres version that I want to create, and here it gives me some hints. But basically, I can select here. Oh, sorry, by the way, I'm not where I should supposed to be. I was supposed to be here. We can select the Postgres version that I want to specify, and I can say latest or 12 or 11 or a given specific minor version. Now, minor version upgrades are kind of easy because we just need to restart the containers, and because restarting the containers may also require to drain the traffic beforehand. That's why we introduced this envoy proxy, because we can control with the API the envoy proxy. We can drain the traffic slowly until a given container is empty, and then restart it elsewhere with the new version. So minor versions upgrades are super simple. Major version upgrades, it's something we're gonna tackle later on. Right now, StackGres ships with Postgres 11 and 12. By the time you want to do a major upgrade version, that will be 1 year from now. And we're gonna develop this code for them to do the major version upgrades. But the process is gonna be more or less similar in principle. So StackGres will take care of this completely automated for you. It will involve a small downtime because you need to turn off the cluster in case of a major version upgrade. We'll perform with PG upgrade, and then we'll bring back all the nodes online. But this is not required right now. If you start with 11, you might want to upgrade some point to 12. But in that case, plan ahead of time and start with 12. And there's no even 13 right now, so you cannot do a major version upgrade.
So maybe one from me, like if you've got like disaster recovery scenario and you are like recovering from this S3 bucket, then there's an option like to use like multi-thread restore, or it's just like one thread and you need to spin up like another, Postgres.
So it's a very good question. Actually, if we go to the backup configuration and we click here in advanced, there's some options like that can control this, like the upload disk concurrency that allows you to select which number of parallel streams we may use to bring this backup from the cloud storage. So this may help with this part. And yeah, that's it. So there's this number of concurrent streams.
And it's both for creating a backup and restoring, right?
There's equivalent configuration for restoring. And when you restore a cluster, so actually we can check here. If we again go to advanced and we select the backup, no, I cannot specify, there's no backup here. I cannot specify the restore configuration, but on the CRDs, which should be here, if I go to the StackGres.io website and here documentation, and instead of the latest, I select the latest version we're talking about right now. This one is not released yet. Sorry about that. Then you look at the Postgres cluster management and we go to backups. So there is here, oh, sorry, this is the backups on the backup configuration. Well, I don't see it right now, but there is also an equivalent parameter for restoring, right?
Okay, thank you.
Oh, sorry, on the restore object is here. Yes, so there's the download disk concurrency. So this is the name of the parameter you would use in this case for this.
Okay, great. Another one from Tomek. Do you support private container registry? In big enterprises, usually companies have private container registry which hold only approved images, and the cluster is configured to be able to use only this container registry. and signed images as additional level of security?
Yes, this is a very good question. And it is something that definitely we're going to do. It is not done right now. Right now, it is served from public registry. Additionally to the open source version of StackGres, there's going to be an enterprise version, which as of today will not include any extra functionality. Yes, support by us, and it will be provided from private registries. So this may solve some part of this problem. But then for companies, enterprises to have this, on their own private registry with their own signing mechanisms, it is something that is not done yet. But if you or anyone else that you know has this use case, just get in touch with us, because we're happy to take on those conversations.
Oh. Okay, thank you. And like another one from Juan. Sorry, not really clear the restore process. Do you need to create a new one to restore? Is there a way to do a restore in the UI to a current cluster running?
Well, this is a very interesting question. Reality is no, but this is because the different mentality between a container environment and a real environment, right? On a classical environment and a VM, you will want to restore in place, right? But in the container world, this doesn't make any sense. There is no difference between restoring and creating. Because you're gonna create the containers, and I mean, containers takes 1 second to start, a few seconds if you can take into account all the containers, and the data is external to them. So there's no notion of existing cluster. You're killing the cluster if you restore data on top of it. So yes, we are creating a new cluster because it doesn't make sense anything else. You don't have persisting data there other than the data. In the data is what you're restoring, yeah, right? So that doesn't make any sense. This concept on a container environment. So it's a feature more than anything else. You don't need to restore an existing thing. You just create a new one.
Okay, if I can like another from me, because you need to like have for the backup, you need to have like S3 buckets. So I assume those needs to be like pre-created, right? Before
Yes.
running the whole stuff.
Correct.
And I assume that those like buckets have got like some kind of size limit, right? On the
No, these buckets. So right now we support these 4, if you can see on the screenshot and the screen, these 4 types of cloud storage: Amazon S3, API compatible systems with Amazon S3, Google Cloud, and Azure Blob Storage. And any of the systems can store unlimited amounts of information or really high limits.
Okay. And actually, can you like, because you know in the cloud environment you've got like an option usually like to create a geo replica, and do you have this option here? Like you can say like I want this my master to be in UK South region and I want the replica to be in the UK West, for instance.
Yeah, so right now, as for the backups, you can use the geo-replication of the backups storage systems from the cloud vendors. As for the cluster itself, right now it doesn't support replicas on a geo-replicated, but this is one of the most requested features that will go after 1.0 DA release.
Okay, thank you. Another one from Tomek, where's Jagger tracing here in SD?
So there is not. I mentioned Jagger as just an option. Jagger is more targeted to probably to applications that you may run, programming applications. We're doing a lot of monitoring with Prometheus, and that's our main focus right now. Not tracing, because you're tracing Postgres, or what are you tracing actually? So I mean, you could trace the StackGres controller itself, but that's more kind of for debugging purposes for the developers, for people like us or other developers that join us. But it's more targeted for applications.
Okay. So there's another question from Juan, which is like he continues the previous one, but continuous protection. Database corrupted due some error in the code, and you want to go back in time. So you would need to recreate cluster, change endpoints, and apply that latest data layer, But what if the data layer was in the point where the data were corrupted? I mean, all those situations where at some point we were Jagger. Observability to microservices where tracing applies maybe better. And thanks again.
Yeah. So I think that was a bit also mixed with the previous one, but about the backup. So, I mean, if you have a corruption in your database and you want to do a point-in-time recovery, a PITR, and go back in time to a point where you believe database was not corrupted yet, you, in my opinion, you really, really want to do that, to spin that PITR in a separate cluster. You still want to keep the one that you have as is, because there you may have corrupted data, but you have modern data. If you do a PITR, you may have safe data, but old data. And maybe you want to do a mix of both. I mean, maybe you probably want to start with the old but correct data, but start feeding back, backfilling data from the corrupted cluster. So I see really no point on restoring by deleting everything. But if you want to do that, just create a new cluster from the PITR and delete the first one. If they will have the same name, and then the DNS will be exposed the same, so you don't need to change anything on the application. And the container world, this is equivalent operation. So just delete the old one. If you really don't care about the data, okay, go and delete it. Once you're deleted, the name you can reuse the same name with the new cluster, restoring from the backup with PITR, and you're good to go.
Okay. And since there's no other, maybe just from me another one. Like, are you aware, like, about Azure Arc?
Azure what? Sorry?
Arc, A-R-C?
No.
Ah, okay. So, because, you know, I'm mentioning that because it's quite, I would say, like similar approach, because Satya, like during the last Ignite, just announced it, and actually that is like under heavy development now. So it's like in private preview, but it's actually a very similar concept. So it's, yeah, so it's Postgres, but for now it's like Citus. So hyperscale Citus on Kubernetes, and it's supposed to be run everywhere, like on every cloud, and you've got like Azure UI to control the Postgres cluster, like from that is running on GCP or something. So,
oh, very cool. I'll definitely need to have a look at that.
Yeah. Another question: have you scanned your images for security holes with OWASP rules or twist lock scanner? So you could say, yes, we are compliant.
Yes, this is a very, very good point. This is also a task that it's work in progress right now, and it's going to be ready by 1.0. It's critical for us, extremely important. It's planned already. There are several security scanners for this. By the way, it's also important to note here, so that's going to be there, no question. And also it's very important to note here that we are our base layers. We're using UBI images, UBI 8 images from Red Hat. These images, if you're not familiar with them, are built with all the security standards from Red Hat and all the updates from Red Hat security, while at the same time are minimal container images. The base images is less than 19 megabytes, and they are freely distributable and useful, so you can use them at will.
Okay. Okay, thank you very much. I think that we like took you like way too much time anyway, but I think like it was super interesting for most of the people, like judging from the questions, the amount of that.
I hope so, yes.
Yeah, so do you have any more questions, guys? Okay. Yeah.
Don't worry. Next year.
Just what are you using for backups? Yeah.
Volg.
Volg. Okay.
Thank you.
So I will do some cutting of the video and we'll upload it to our YouTube channel. Do you want me like to cut off the Q&A part or just leave it like it was?
No, as you want. Everything is okay for me. So we can leave Q&A or not. It really all depends on you, as you wish.
Like everything. So yeah, like cutting and mixing with some random pictures from the internet. Like it's okay. I think.
Absolutely.
Okay, good to know.
No shame.
Okay,
I think people are saying to leave the Q&A. So yeah, happy to do that.
Is it production ready?
So we are starting production workloads, even though it's still evolving. So we are approaching 0.9. There's already workloads, production workloads, and we are aiming for a GA release in late May or early June. So yeah, feel free, go and start testing it. If you find anything, just drop an issue on our GitLab, and we're happy to use it. But you know, it's running already several workloads.
Okay.
Okay, how long it's been in development? More than approaching 1 year, actually. Approaching 1 year. With a lot of people. So it's been a huge effort. Actually, I have to say, just to close this, that I'm really proud. We have a superb team behind this project. There's at least 10 people involved in this project, and different times, and they've been doing a really hard work to pull this out. So I would really encourage you to give it a try, to report any issues to us, to collaborate. This is open source. Go and hack the code, send us patches, send us improvements, and and send some love with this team that has been fantastic.
Okay. Yeah, I think that was like all. So thank you very much, really, for the session. I think it was really interesting.
Thank you very much for the invitation, actually.
Okay, so have like great evening, and see you on Ibiza like next year, I think.
Yeah. Okay. Goodbye, everybody.
Bye.
Thank you for attending, and thank you for the invitation.